we're going to work on this question here, which is just algebraic manipulation of some radical numbers. So, oh good, the second wasn't working. What we want to do here is these roots make it pretty difficult to work with. In fact, we have a single root on the right side of the equation. So what we're going to try to do is eliminate that root. And to eliminate that root, you have to use the inverse operation. The inverse operation for a square root is technically just the power of 2. So an old algebraic rule is whatever you do to one side of an equation, so we're on the right side right at the moment, our right side of our equation, that's an S, we have to make sure we do to the other side of the equation, okay? And this happens to be the entire left side of the equation. Now, that whole side's going to be put in the brackets because that's going to be important for us. We're going to have to do some extra steps with it because all of it is in brackets, not actually each individual form. What's nice about the right side of the equation here is these operations, they cancel each other out. If you want a side note to why that happens, I can technically rewrite this to the power of a half to the power of 2. And I don't know if you remember powers of powers for exponents. You just multiply the numbers. So a half times 2 is actually just equal to the power of 1, which is really nothing. It ends up just being x plus 2. So that's why that cancels out. Okay, that's a little side note. The other side, though, we have to do binomial distribution. We need to take the square root of 2x plus 5 minus x minus 1 square rooted times the square root of 2x plus 5 minus the square root of x minus 1. I don't know why I condensed myself so much there. I had so much extra room. There we go. Okay, so we got to do, maybe you recall it as FOIL, but it's essentially taking the very first term, multiplying it by both terms in the second bracket, and taking the second term and multiplying it by both terms in the second bracket. So we'll carry out that process. That part could be a little tricky. What's nice about it here is I'll write each of them out. I'll go down one more line and write each of them out here. That way we have a step-by-step version of it. But this is essentially square root of 2x plus 5 times the square root of 2x plus 5. So you might be wondering to yourself, oh my, what do I do with that? Okay, that's the first ones. Okay, we'll call them the first terms. And then we have the outside terms, they call this piece. This is the square root of 2x plus 5 times the square root of x minus 1. Now, the only thing is that's technically a negative, so I'm going to change this operation in front. I'm going to change this to a subtraction sign, just because it's a negative times a positive value. Are you okay with that idea?
Yeah.
Yeah? Okay. So those are the outside terms. I'll put that in black. We'll call it the outside terms for our FOIL. Then they do the inside terms. So that's these two green ones here. Same idea. I have a negative, so I was going to say subtract x minus 1 times the square root of 2x plus 5. Okay. It's getting real messy here. Those are the inside terms. And then lastly, what color is? Do I have any colors left? Blue. We haven't used blue yet. The last terms. Oh, I should have knew that. This is a negative times a negative, so it's actually be a positive value, and it is square root of x minus 1 times the square root of x minus 1. Okay? All of that is still equal to what's left on the right-hand side. These are the last terms here. Now, we got to figure out... No. We got to figure this piece out now, is we have to multiply our values together. We have a... we have a square root times a square root. So there's a really fast way of solving these square roots. Think of it like this. If you have the square root of 5 times the square root of 5, that actually just equals the number 5. So whatever's underneath those square roots, we just keep that one term. That's all there is to it, okay? If you need a proof of that, I can give you a quick one. Think of it like this. Square root of 2 times square root of 2. I should say 4. 4 is an easier value. 2 is the answer to it. The square root of 4 is 2, and square root of 4 is 2, and that equals the number 4. So really, we could have just kept the term underneath. So we're going to do that here. We're going to keep 2x plus 5. That part's done. Our first terms are dealt with. Our second terms, we can't really simplify nicely. So in fact, we're going to keep them as is. What is nice about them, if we take a look, is this term and this term are the exact same. They're just in a different order. It's known as a commutative property of multiplication is that you can order it any way you like. Now, think of it like it's a -1 and a -1. So when we put them together, the idea is actually becomes -2, and then I'll put them in brackets, the square root of 2x plus 5 times x minus 1. That's essentially what's happened. We have two of them. That's all that's saying. And then the very last term here, we have x minus 1 times x minus 1. We just keep the term underneath, x minus 1, okay, is equal to x plus 2. So now that we've done that, okay, we are going to try to collect like terms. Things that are similar, keep them on one side of the equation. Things that are different, we'll put them on the other side here. So in this case here, we have our 2x, we have an x. Let me just make sure we didn't miss anything here. Yeah, that's right. Yeah, that's okay. Okay, we have, I'm going to keep this -2 in the set of brackets on the left side of the equation. And then we're going to just bring everything else to the other side of the equation because we have variables here and we have constant terms. And we're going to put them all together, okay? So this 2x will become -2x over here. This x becomes -x, and this becomes plus x. Okay? And then 5, -1, and 2, that becomes -5, +1, and +2. Okay? We're going to collect our like terms of our variables. -3. So -2x minus x plus x is just going to be -2x. And then our constant terms, -5 plus 3 is going to be -2. So now we have this, -2, 2x plus 5, x minus 1. Okay. We can divide everything by 2. And if we divide everything here, you'll notice there's technically a 2 on everything here. We can divide everything by 2. That's going to reduce all of these to the value of 1. Okay? So when we do that, we have -2x plus 5, x minus 1 is equal to x minus 1. We'll put our brackets around it here. Okay. Now, we have these roots, and we need to do something to deal with these roots. So let's take a look at these here. Sorry, I missed this one piece. This should have been a negative here. And what we could have done is we've divided by -2. The negatives would have all disappeared. So let's actually divide by -2 here so that all of these things become positive values. Okay, we have this set of brackets, and it's tricky to deal with. We have roots underneath them all. We did this before. We squared each side to get rid of roots. So we can square the left side. Just if we do that, we have to make sure that we square the right side of the equation. When we square the left side, there's no negative or positive, so addition or subtraction between it. So actually this one here becomes like this. It's just one large term. So it looks like this, square root 2x plus 5 times square root x minus 1 times square root 2x plus 5 square root x minus 1. Okay, and I'm going to keep the right side here the same. When you do that, like we talked about before, we just keep the values underneath the roots. So you get 2x plus 5. Okay, that's one set of values. And then you have times x minus 1. That's the other set of values. On this side here, you have x plus 1 times x plus 1. So a whole bunch of FOIL again. I'm going to go through this part a little quicker because there's no roots in this one. So I'm just going to jump right to the next piece. This gives us 2x squared minus 2x plus 5x minus 5. On this side, we get x squared. This will actually become 2x and then plus 1. We can collect like terms, set this thing equal to 0. That's the best way to solve. This is essentially going to be a quadratic now. So I'm going to move everything from the right side over to the left. So we're going to end up with 2x squared minus x squared, negative 2x minus 2x, plus 5x minus 5. Going to get rid of these equal sign. Minus 1. So all the ones in red are what we moved over to the other side. And 0. When we work them out, this becomes x squared. These Well, that becomes negative 4x plus 5 is positive x. And this becomes negative 6 is equal to 0. From here, you can factor to solve for your value of x if that's what it's asking. You can use quadratic formula. That's essentially, I think, where they decided to stop your question. But there's quite a bit to this question here. There's quite a bit of algebra, and understanding your radicals becomes a big part of this